Hi student, this is Sendil Selvi, Professor, Department of CSE, SRM Institute of Science and Technology, Ramapuram. Today we are going to discuss about the hierarchy of fog edge computing. In the last video, we discussed about the basics of fog edge computing and advantages of fog edge computing, how fog edge computing complete the cloud-centered IoT architecture. Now we will move to the hierarchy of fog edge computing. Fog edge, the hierarchy include three, actually in the cloud-centered IoT architecture, we can deploy the fog edge computing servers in a three layers. There are inner edge layer, middle edge layer, outer edge layer. First, we will see the diagram. This is the diagrammatical representation of three-layer deployment in the cloud-centered architecture, IoT architecture. So see here, we can deploy the fog edge computing nodes in three layers. This layer is called inner edge. It's nearer to the cloud core architecture, inner edge, middle edge, outer edge. We will see one by one. First one is inner edge. The inner edge is also known as the near edge. It includes a WAN data center as well as data centers of evolved packet core. So this WAN data center enabled with the geo-distributed caching and processing mechanism. This mechanism will improve the quality of service in quality of experience in the web services. What is a geo-distributed caching and processing mechanism? It refers to a system where the data is cached across the multiple geographically dispersed server. It closes to their location to reduce the latency and improve the performance. And one more thing, this layer consists of evolved packet core data center, which provide the converged voice and data service on a 4G long-term evaluation. So simply we can say the WAN-based cloud data centers can be considered as the fog of inner edge. Next, we are moving to middle edge. The middle edge consists of two types of network, local area network and cellular network. Local area network include Ethernet, wireless LAN, campus area network. The cellular network consists of macrocell, microcell, picocell and femtocell. Now we will see one by one. Explicitly, middle edge covers a broad range of equipment to host FEC servers. First, we'll discuss about LAN. Normally, the emerging fog computing architecture introduced by Cisco Research utilizing internet gateways, which has virtualization technology. That technology allow the gateway device automatically support the FEC mechanism. So, if the virtualization technology enabled server computers connected with the same subnet of LAN or CAN, it is called the local cloud or local data center or cloudlet. Next, we will move to the cellular network. What is cellular network? Actually, in a modern era, that is, all the cities are modern cities are have a broad coverage area of the cellular network with the enormous numerous types of BTS. What is BTS? The BTS is nothing but base transceiver station. It is a fixed radio transceiver. It convert the mobile, it connect the mobile devices to the network. So this feature enable the major telecommunication infrastructure and equipment provider enable their hardware and infrastructure with MEC. What is MEC? The MEC is called multi-access edge computing or mobile edge computing, which moves the computing closer to user. It reduces the latency and improve the performance. In the first inner edge layer, we discussed about the geo distributed caching and processing mechanism. This makes the data closer to the user. It also reduces the latency and improve the performance. Here, the MEC makes the computing closer to the user. So it is also reduce the latency and improve the performance. So this MEC enabled hardware and infrastructure makes the FEC will available in broad range of related equipment to the indoor equipments. So the broader range of equipment includes macrocell and microcell BTS. The indoor cell equipment includes the picocell and femtocell base station. Next, we are coming to the outer edge. The outer is also known as extreme edge, far edge, or mist. It consists of three types of devices: the constrained devices, integrated devices, and IP gateway devices. First, we will discuss about the constrained devices. The constrained devices normally operated with limited processing power and memory. So the example for that is sensor and actuators. It is operated using microcontrollers. Normally, microcontroller have very limited processing power and memory. But these devices are inbuilt with the field programmable gate array, that is FPGA. This makes the devices to communicate themselves without relying on the distant cloud. Then we are moving to the integrated devices. These devices are operated by the decent power and the decent storage memory. So it won't depends, but when comparing the constrained devices, it has only limited memory and limited storage. But these integrated devices have a needed amount of processing power and memory. Next, we are moving to the IP gateway devices. Actually, hubs or IP gateway devices it's act as a mediator between the constrained devices and middle-aged devices. Normally, that is because of the need of the energy efficient wireless communication, the many constrained devices do not operate in the IP network. Actually, which is requires very energy intensive Wi-Fi connection. But the constrained devices are communicated using the protocol that consume. Actually, they need the protocol which consume lesser energy. Since the low energy communication protocol do not directly connected with the IP network. It makes the system would use the IP gateways to relay the communication messages between the constrained devices and the internet gateways. Hence, the backend cloud is capable of interacting with the front-end constrained devices. Okay, I will summarize what we discussed in this session. Hierarchy of fog edge computing. So it consists of the fog edge computing implemented in the three layers in a cloud center architecture. The first one is inner layer, second one is middle layer, last one is outer layer. The first inner edge consists of WAN data center and EPC data center. WAN data center enabled with the geo-distributed caching and processing mechanism. The middle edge layer consists of local area network and cellular network. It covers local area network and cellular network. Local area network implemented using the internet gateways with the virtualization technology. And cellular network, actually modern base stations have the capability to cover the roadside IoT devices such as mobile vehicles, healthcare. That devices are connected by the BTS, base transceiver receiver. That's why telecommunication provider, infrastructure and technology provider, they're providing MEC enabled technology that make the equipment available with the FEC services. The outer edge, the last one is the outer edge. It consists of three kind of devices: constrained devices and integrated devices and IP gateway devices. If we simply say a constrained devices operated with very limited power and storage, integrated devices operate with decent processing power and storage. IP gateway devices acted as a intermediate between the constrained devices and integrated devices. This is the reference book I have referred for preparing this PPT. Thank you, students. We will meet in the next session.